A ball of mass 0.1. Now I'm assuming that's 0.1 kilograms. Okay, they probably didn't finish off their. Does it say 0.1 kilograms in your book? Interesting.
No.
So, it's a 0.1 kilograms. Okay. Moves horizontally with speed 25 meters per second towards a smooth barrier XY, which makes an angle of tan inverse. I'm going to let A be equal to this angle tan inverse 7 over 24. Therefore, we're going to make a triangle A, where it's going to be 7 is the opposite, 24 is the adjacent. I'm sure it's 7, 24, 25, isn't it? So 25 is the hypotenuse. Once you do Pythagoras' theorem. Okay. Now, the coefficient restitution, the E value is 3 over 7. Okay. Find the speed of the ball after impact, correct to 1 decimal place. Now, once again, what this whole system does to me is, it basically, because it's not lined up in the usual manner, it confuses your brain of something that you might think is easy or otherwise. So, all you gotta do is just turn it around like so, and we'll just make this diagram a bit bigger, and then there you go. So what I can now do is I can now continue on this line, not like that, I won't, like this, and long and behold, it's not perfectly straight. It's slightly going to annoy me, so I'm going to fix it. Roughly. Okay, so there you go. That's my new axis, and that's the ball coming in. Okay, and that's still XY. So what I'm going to do is, we can see that these are vertically opposite now, can't we? So we know that that's angle A. So I'm going to break it up into its 2 components. Can anybody tell me what component this is going to be? Remember, it's 25 coming down this way. So anybody know this one here? It's the opposite side, right? So sine or cos? Make a choice. 25 sine A. And the other one is 25 cos A. Now, we already figured out what sine and cos are. Sine is, oh wait, we haven't actually. Sine A is 7 over 25. Cos A is 24 over 25. So, this means that 25 sine A has to be what, guys? 7. And what's that mean about 25 cos A? 24. Okay? So it means that you're coming in with speed 7 going downwards towards the plane, and speed 24 going this way. Now remember, the plane is in the, it's along the x-axis. Which component of the speed is therefore affected when it bounces back out again? Will it bounce back out at the same angle, or will it be a shallower angle? Or will it be steeper? You tell me. Why is it shallower? Huh? So the reason why it's shallower is the speed that's parallel to the plane doesn't get affected. The 24 is completely unaffected. Okay? It's like when you hit a snooker ball against the table. The speed going speed going parallel to the cushion is unaffected. It's the speed that it goes into the cushion that gets affected on the way out. So, long story short, I'll just make this a bit more obvious. This is your barrier here, and the 24 is in line with that barrier, so the 24 will remain the same. Okay, and then on the way up, it was 7, so it's phi equals minus EU. Your final velocity equals minus your E value. My E value is minus 3 over 7, and my initial velocity was 7. It means it's going to come back up at a speed of 3. So 24 across 3 up. Find the speed of the ball after impact, correct to 1 decimal place. Does it want the velocity or the speed? Speed. And what does speed mean? Find the hypotenuse. Hypotenuse is 3 squared plus 24 squared. Square root it. And you get 3 root 65. which is 24 point, what's the one? 24.2. Okay, so 24.2 on the way out. Find the magnitude of the impulse due to the impact. Anybody remember what impulse is? Impulse, anybody?
MV minus MU.
MV minus MU. Okay. So, impulse equals MV minus MU. Okay. Interested to see what way they did this. Yeah. Yeah. Okay. Because the impulse only takes place in one direction, I can take the impulse along the J direction only. Okay, that'll make things easy for me. So, because it maintains its 24 on the way in and on the way out, that has nothing to do with the change in momentum. So I'm going to look at the change in momentum directly associated with the change in momentum directly associated with the 7 and the 3. Okay? So what we're going to get here is it's going to be m times phi. So 0.1 times what's phi? That's going to be that's technically let's call it plus 3, I suppose. Then minus your initial velocity. Should it be a 7 or a minus 7? Why is it a minus 7? Yeah. And then it's going to be 1. Okay. So it's going to be 1, and what? It's the units of momentum. What's the units of momentum again? Kilograms meters per second. Kilograms meter per second, and it's going to be in the J direction. Okay. So that's the direction it goes in. Okie dokes. So that's your impulse there. Okay. Next part wants the loss in kinetic energy to the nearest joule. Okay, so loss in kinetic energy. So what we can do here is loss in kinetic energy equals Ke before minus Ke after. Ke before, and what's kinetic energy? Formula for kinetic energy, anybody? Formula for kinetic energy? Nobody? Half mv squared. A half times 0.1. You're coming in at 25. You're leaving at 24.2. So a half 0.1 times 24.2. So let me put that in the calculator and tell me what you get. I'm hoping it comes out as 2. So it's 1.968, yeah? And that's very close to 2, so roughly 2 joules knocked off, okay? Now, number 25. Smooth metal sphere falls vertically and strikes a smooth plane inclined at an angle θ to the horizontal. Coefficient of restitution is 2/3 and the sphere rebounds horizontally. Calculate the fraction of kinetic energy lost during impact. Okay, that's a difficult question, to be honest. Probably as difficult as you'll get in this exercise. So, I'm just going to do what I usually do. I actually simply can't handle it in that direction. I always have to rotate it. Now, there might be one problem with that though. It's the falling part, isn't it? There might be gravity involved, so I'll have to see about this. It doesn't tell you. It doesn't tell you how much. It doesn't tell you how far it's dropped from, does it? So it's more abstract than we give it credit for. Okay, so kind of rotate around like last time, and here we go. Perfect. Okay. Now, let's see how to construct this. Alright, got it. Lucky there. It's theta. Any reason why that's theta? Alternate angle, right? Everybody sees it? There to there to there. Okay, here's your alternate. Now, this here has to be 90 degrees. Any reason why it's 90? It was dropping straight down and it came out going straight across. Okay? And then finally, this whole thing has to add up to 180. That therefore will make this part 90 minus theta. Okay? So we got a wee bit of information there. Now let's do the before velocities, okay? One thing I also want to show you is, let's see if you get the gist of this quite quickly. Cos 30 equals sine 60. Everybody agree with that? You've used it enough to know. Cos 45 equals sine 45. Cos 60 equals what, guys? And finally, cos 70 equals sine 20. What's the common thing there? When you add both angles together, you get 90. Therefore, cos theta has to be equal to what? And vice versa, sine theta equals cos 90 minus theta. The top two are what's relevant to our cause at the moment, okay? So just put them up there for a minute. Okay. So lads, we're going to break up this into its components, okay, hitting the axis. So what we're going to have is it's going to be I suppose I could just call that theta, couldn't I? Make the whole thing a lot easier. Why am I allowed to call that theta? It's a right angle triangle, isn't it? So if I was to just construct this a bit more, we have that there is going to be 90 minus theta down here, which makes it theta up there. Sorry, eliminates the need for 90 minus theta if you were to use it that way. So, can anybody tell me what this side is here? I'm going to shade it in blue. Anybody got any ideas about that one? U cos theta. Anybody have any ideas about this one here? U sin theta, okay? And both of them are going to be negative, okay? So, velocity before is going to be minus u cos theta, minus u sin theta along I, and then along j is minus u cos theta j. What about velocity after? Velocity after, anybody? Phi. That's going to be phi cos theta, and this one here is going to be phi sin theta. So it's going to be minus phi cos theta, and the other one's going to be plus phi sin theta along j. What two values have to be the same? I'd argue that this one here and this one here have to be the same. Can anybody tell me why? They're parallel to the plane. It's the velocity component that's parallel to the plane you just hit. Remember the last question, that didn't change from 24. This question is no different. It can't change. Therefore, what you know is that u sin theta has to be equal to phi cos theta. Okay? That's your first equation. Okay? So we call that equation 1. Equation 2 is the E value equals what, guys? E value equals 2 over 3. So to get your second equation, what you know here, guys, right? Phi equals minus EU. Everybody see phi equals minus EU? Your final velocity, which is phi sin theta, equals minus E, which is minus 2 over 3, times your initial velocity in that direction. What was your initial velocity in that direction? minus u cos theta. We're next going to get that 3 phi sine theta equals 2u cos theta. Everybody see that? Now we're going to have to combine both equations with each other. Okay, so how do we go about doing that? I suppose I'm going to get u over v, maybe sine theta. Yeah, I have an idea. Sine theta is equal to phi cos theta over u. Everybody happy with that? And then sub it in. 3 times 3v times phi cos theta over u equals 2u cos theta. Next thing we're going to get, the cos theta's cancel, and we're going to get 3 phi squared equals 2u squared. Yes, I think that's what we got anyway. But I cross multiplied to u. See, the u goes up beside the other u to give you 2u squared. Sorry, it's my bad, I should have done 2 steps. Okay, question is directly relating. Calculate the fraction of kinetic energy lost during impact. Calculate that fraction of energy, okay? So, calculate that fraction of energy lost before impact, alright? So, we're going to do K before and KE after. Now please remember, guys, on your initial diagram it came in at speed u. If you remember this, it comes in at speed u and leaves at speed v. KE after is a half mv squared, KE before is a half mu squared. Okay, so that's before and after. Now, it specifically says it wants the fraction of kinetic energy lost during impact. The fraction, okay? So what that means, to calculate the fraction, you're going to have to do it like this. Ke before minus Ke after all over kinetic energy before. So, it's going to be a half mu squared minus a half mv squared all over a half mu squared. Now, what's the only thing stopping us from dividing that out right now? The fact that the u's and the v's are incompatible until we got this here. So phi squared is therefore equal to 2 over 3 u squared. So change your phi squared into 2 over 3 u squared. Safe to say that all the mu squareds are going to cancel now, and you're going to have a half minus a third over a half, and I'm pretty sure that turns out to be and it is so what's that? It's going to be a sixth on top divided by. Okay, my brain's not in this at the moment. It's a 6 divided by a half. Okay, lads, 1/3. So the amount of energy you lost is 1/3. How much energy was preserved then? 2/3. What's 2/3 exactly the same as? The coefficient of restitution. Would it be therefore fair to make an assumption that if that was 5/7, we'd lose 2/7 and we'd maintain 5/7? So there is a trend there, okay, so you have to be aware of that trend. You'll obviously have to prove it, but